You're ready.
All right. Do this. All right. Thanks, Mark, and good afternoon, everyone. So I'm Emily Ohde, and I'm an environmental assistance specialist with Minnesota Pollution Control. I focus primarily in air quality and provide technical assistance helping businesses understand and comply their environmental regulatory requirements, as well as pollution prevention and reducing their regulatory obligations. And I'm going to start today discussing the situation with trichloroethylene in Minnesota. So to provide some background to the topic, TCE is a man-made chemical that can be a liquid or gas. It's mainly used as a solvent in manufacturing to degrease metal parts, but can also be used in the production of industrial chemicals and in a variety of products such as wood finishes, glues, adhesives, paint removers, etc. So TCE readily evaporates into air and moves from water to air easily. So if TCE is spilled, it can move readily underground where there's a risk of contaminating drinking water wells or rising through the soil and entering buildings through vapor intrusion. And many Minnesota businesses use TCE in their industrial process and operate under MPCA air permits, regulating how much TCE can be emitted. As a hazardous air pollutant, it is tracked by many of our air permittees. However, the reporting of hazardous air pollutants is voluntary every 3 years during emissions inventory. So TCE can also be used by some businesses in small enough amounts that their use is not regulated. They're not required to obtain a permit. Our Minnesota Department of Health provides information about the potential exposures and risks to chemicals that are in the air. But in 2018, they lowered the health-based value, also known as your inhalation health benchmark, to 2 micrograms per cubic meter per 24-hour averaging time. So breathing TCE vapor certainly is not the best for you, especially at high levels or over long periods of time. Can very well cause negative effects to reproductive systems, liver, kidney, and long-term exposures include different types of cancer. The inhalation health benchmarks are much lower than regulatory limits that are set for workplace where the chemical is used. But when these are exceeded, when the inhalation health benchmarks are exceeded, it's recommended to begin taking those steps to reduce or avoid exposure. Our Minnesota TCE Initiative began in early 2019, along with the new inhalation health benchmarks and an investigation into possible community exposures to TCE from a manufacturer called Water Gremlin. They operate under an individual state air quality permit from MPCA and make fishing sinkers and battery terminal posts. In January of 2019, MPCA requested Water Gremlin voluntarily shut down part of their process. It was discovered that the company was emitting too much TCE into the air. The company did comply, and MPCA began investigating the extent and magnitude of emissions. And MDH was helping to understand the potential health impacts for the community. So it was discovered that Water Gremlin had about 15 years of inaccurate data reporting with exceedances of TCE. And in March of 19, there was a stipulation settlement with $4.5 million civil penalty, along with requirements for new control equipment, conducting those in supplemental environmental projects, and doing an investigation and cleanup of contamination on the property. The facility then switched from TCE to use TDCE as a less toxic alternative. But by August, there was an order to stop the use of TDCE. Part of our sampling showed TCE TDCE and lead in the air, ground, and surface water on that property. And the lead pollution was due to faulty particulate control equipment. But in January this year, they've resumed coding operations, and they have to do regular reports, daily reports of TDCE use, pound per hour stack emissions, and ambient air sampling for TDC and lead. So getting down to the legislation aspect of this, our Minnesota legislature provided funding for 1 full-time employee to MDH and 2 full-time employees to PCA to essentially study TCE. Our PCA permitting and risk analysis groups began working together to develop a list of facilities using our emissions inventory data for those facilities that submitted TCE emissions during the 3-year voluntary surveys. And those occurred in 2011, 14, and 17. So they also were able to gather together the permit limits that are listed in our database, identify facilities that had annual submissions for NESHAP-T for those halogenated solvent cleaning, TRI data, and they had a list of known degreasing facilities that had been previously provided by EPA. So all of the facilities that they gathered were contacted, and a request for information went out from our compliance and enforcement folks, and it equated to about 110 facilities with suspected TCE emissions. And by January of this year, all of them had responded with their current TCE use and steps that they've taken to reduce or eliminate TCE in their operations. To give a more holistic view, additional information was added to the list of facilities, including their potential and actual emissions, their permit type, facility address, and whether the facility was in an area of environmental justice or as an active or closed remediation site. So using all of this data, MPCA ended up with a prioritization schedule of this list, specifically looking at the risk that their TCE emissions were causing concentration levels at their property exceeding the short or long-term health-based values. The values were modeled on our MinRISC 2011 if the facility reported those TCE emissions in 2011. And they obviously, here you can see, gave highest priority to facilities that were exceeding the health-based value. And then the ones that we didn't have risk values for, but did report greater than 400 pounds per year of TCE in emissions inventory. And then the third group is those that had actuals greater than that health-based value, but not very much TCE emissions in 2014 and 2015 or 2017, excuse me. The last grouping here, facilities that have a risk below the health-based value and a PTE greater than 400 pounds per year, or actual emissions below 400 pounds per year of TCE. And the last group is where the majority of that 110 facilities were categorized because TCE emissions were as a byproduct of combustion, about, I think, 89 facilities or so. But no further action was proposed given their low risks. Meanwhile, we're working on our TCE ban legislation, which was signed in on May 16th of this year. It becomes effective on June 1st, 2022, and applies to sites that are required to have an air quality permit from MPCA. So all facilities have to stop using TCE, and it has to be made enforceable through their air emissions permit or enforceable agreement. MPCA is not allowed to issue an air permit that authorizes use of TCE on or after January of 2022. For small businesses or those businesses that have less than 500 full-time employees, they are able to apply for a one-year extension, so a compliance date of June 1st, 2023. And if facilities are required to comply with the ban and elects to replace TCE with another chemical, they have to replace TCE with a chemical that is demonstrated to be less toxic to human health. So some businesses have certainly already ceased the use of TCE and have chosen to switch to using a drop-in replacement of another halogenated solvent, which many of those also have serious health and environmental impacts. Many of them are currently undergoing more research or need more research or be subject to increased regulation in the future, such as like N-probobromine. From the small business perspective, aside from a possible one-year extension period for their compliance, a facility, again, is not subject to the ban if its permitting or its potential to emit is below our permitting thresholds, or if it's exempted from needing an air quality permit. So in January of 2019, MPCA had new rules become effective, which actually broadened the ability for small sources to be exempt from permitting. And some of these could include those TCE emitters. In the statute, there's 3 cases in which PCA is going to grant an exception to using TCE. The first one is using TCE in closed systems without TCE emissions from the facility. And my understanding that this is very difficult to do or prove as a business function. The others are holding TCE or products containing TCE for distribution, and then hospitals that are licensed or academic medical facilities. There's 2 variance possibilities where PCA may grant an exception, but those are for facilities that use TCE exclusively for research and development or other lab or experimental purposes. And then those facilities that process TCE for waste disposal. So these 2 have to go through a variance process, and a condition with either group is their required compliance with the health-based value and health risk limits for TCE established by Department of Health in January 2019. So that includes those facilities that are under the exceptions, has to comply with that health-based value. And PCA has already begun discussion of modeling and risk assessments for those that have indicated an interest in the variance and those that may fall under the exceptions. So as stated with the prioritization of initial TCE emitters, many of those emit TCA as a byproduct. Or those facilities that have less than 400 pounds per year of TCE emissions. And so no further action was proposed for them given their risks, or their very low risks rather. So narrowing down the TCE emitters, we have 39 facilities that have taken actions that are seen here. For those that have already removed their degreasers or switched to aqueous solvents, and no longer using TCE, no further actions proposed unless a permit amendment is necessary. And community outreach is still going to be conducted or may be conducted around facilities with past emissions above the health-based benchmarks. And certainly communities where it's determined that there was significant potential impacts, MPCA and MDH are going to work with the local units of government and community members to develop and implement outreach and communication plans for those communities. So another aspect to the legislation was the availability of up to $250,000 in small business improvement loans for the purchase and installation of equipment for switching to an alternative that is demonstrated to be less toxic. The TCE loan operates under the same conditions of our existing small business improvement loan managed by our program with MPCA that has a maximum loan of $75,000 with a 0% interest and repayment over 7 years. Although the $250,000 from the legislation was not provided to support those loans. So that amount has been set aside from our existing small business environmental improvement revolving loan fund. And as an update, to date, we have not received any inquiries or applications for a TCE loan. However, there's still plenty of time for businesses to potentially apply for a loan since the ban becomes effective in June of 2022 or possibly even 23 if a small business applies for an extension. So that is all I have for today, unless we want to do questions now, or we can do questions in a little bit.
However you want to do that is fine with me.
Yeah, if you have questions, just unmute yourself.
So, Emily, there was at least 2 questions that did come in from Nancy.
Mm-hmm.
So she asked, did you say that permitted sources only have to report emission inventories every 3 years?
Correct. Yep, it's voluntary every 3 years.
Okay. And have you had any good examples of a TCE closed system?
I know that there was a single facility that was looking at deeming their process closed loop, and there was the presence of a hatch that essentially eliminated the no TCE emissions, because each time they open the HAP, you would have TCE emissions. So as I know right now, there aren't facilities that are looking to qualify as that closed loop process, but Jane may also have more information on that as well.
Okay, and what is the most common drop-in replacement?
So similar to water gremlin, there's the TDCE in propylbromide. PERC is an option. Of course, all of these, so the designation of being less toxic isn't defined, and we don't have a list of chemicals that are more or less toxic than TCE. So PCA is really taking that holistic view at a facility, given the company's choice of alternative and what other pollutants they're emitting at that facility, and even routes of exposure of other pollutants. So Jane will probably have more information about those straight drop-ins that wouldn't take too much configuration for equipment.
I will be talking about those also.
Yes, there you go. Excellent. I will let Jane cover those then.
Okay. One final, Mark did give an example of a potential. It's a particular model airless airtight ultrasonic degreaser, but I think that's a good segue into handing it over to Jane.
It sure is.
All right. Let me just get my slide going. And share my screen. All right. Can everybody see that?
Yep.
Okay.
Great.
Thanks. All right. I'm Jane Paulson. I'm from the Minnesota Technical Assistance Program. And we have been doing some work with the TCE alternatives that we're calling the TCE Alternatives Project. So I'm going to share our information on that. First, I'll give you a very short introduction of who we are at MinTap. And then regarding the TCE Alternatives project, I'm going to talk a bit about the project structure and the administration of the project, what the testing process is for companies that are participating, and some of the outreach that we've done. And then I will go into some of the technical information on TCE replacement, including some of the alternative cleaners and comparing the pros and cons of those various cleaners and equipment options, and then a little bit about next steps. So Minnesota Technical Assistance Program, we're based at the University of Minnesota. We focus on pollution prevention. So we're working to help businesses save money while saving energy and reducing pollution and waste. We were established in 1984 and we're part of the School of Public Health. We are grant and partner funded. The majority of our funding comes from the Minnesota Pollution Control Agency, but we also get funding from a variety of other grants from the MPCA, from EPA, from the Department of Commerce and Energy. And then we also get funding from utilities and a few and small inputs and contributions from the businesses that we work with. Our work is confidential and non-regulatory. We're specifically placed separate from the Pollution Control Agency so that businesses can feel safe to come and ask us for help. If they're like, oh, I think I'm maybe not doing something quite right here, we can help them and they don't have to worry about getting in trouble for it. Almost all of our services to the businesses are also at no cost. Occasionally when we have a special program, there will be some kind of copay. The main one where that is the case is our intern program, but most of our services for them are no cost. We look at reducing hazards at the source, water, chemicals, energy, and we both do assessments and our intern program where we had 21 interns out in companies this past summer, and they had recommended savings of over $4 million. So we're very excited about that. It was our largest group ever. I just covered that, but 2020, we had 21 intern student projects with $4.2 million in savings recommended. These are our 2019 results, 500,000 pounds of waste reduction, almost 30 million gallons of water savings. And these in the state here are the implemented savings. So $1 million of dollar savings and 6 million kilowatt hours of electricity. Trichloroethylene, I think we've covered this, but it is a clear non-flammable chemical. It evaporates at moderate temperatures and is very good at dissolving greases and oils. It's low cost and very familiar to industry, so people have been using it a long time and they would probably keep using it into the future if we didn't have a push to get some changes made. The cons are it's a carcinogen. It can affect liver, kidneys, central nervous system, reproductive system, and fetal development, and it's becoming much more regulated in recent years. Our Minnesota TCE Alternatives efforts, we actually were awarded a grant by the EPA and MPCA partner grant in October of 2018. Just as we were getting ready to launch that program in January and February of 2019 is when the news about the water gremlin company and their emissions that Emily spoke about made the news and brought TCE really to the forefront of interest in Minnesota. So the timing was really interesting for us. We were able to skip most of the outreach that we had planned because as soon as we were ready to get started, we had companies coming to us more quickly than we were able to add them into the program. The approach is to help businesses overcome the barriers to switching away from TCE, focusing on safe but effective options and avoiding regrettable substitutions, which I'll talk about what some of those would be. As I said, the EPA MPCA funding was started in February 2019. It was originally to go through September 2020, but we did get a one-year extension through next September for follow-up. The goal was 4 companies and 10,000 pounds of TCE reduced with a priority on businesses that are in environmental justice communities. When the water gremlin situation happened and they were given a large fine for their emissions overages, They also, part of that settlement was also to provide a supplemental environmental project, and a portion of that came to MNTAP to basically increase and expand on this work that we were already doing. This project and funding goes from May 2019 through March 2022. And the goal is to add an additional 6 TCE alternatives at facilities. And this, this funding has a priority of areas that are within 40 miles of water gremlin, which basically covers the entire Twin Cities metro area. As part of this work, we're partnering with TURI, the Toxic Use Reduction Institute at the University of Massachusetts Lowell. They have extensive experience in identifying and implementing safer cleaning options, including with TCE. Their testing ability is really important to the success of this project because MNTAP does not have any lab facilities. So we would not be able to do any of this testing. And what we found is that most of the companies don't have the capacity to do their own testing, even with support from MNTAP. We did try that during pandemic. TURI was shut down for several months this summer. And a few companies made an attempt to get the information, get the chemical samples that TURI recommended and do some of their testing in-house. But even the largest companies that were able to do that, it was kind of slow going, and the smaller companies just said, no, that's not something that we're able to do. Another thing that was really vital to the success of this project was the willingness of EPA Region 5 to allow part of the funding that MNTAP and the MPCA received in the grant to be used for TURI, which is outside of our region, so that we could do that testing and work across regions. So that was something that we really appreciated. As Emily talked about, there was the water gremlin situation, which got into the news in early 2019 and really raised the profile of TCE and TCE use. A lot of companies were telling us they needed help because they just don't want to be the next water gremlin. And also they were getting more scrutiny as well by MPCA as MPCA started checking on other businesses that were using TCE. This led to the Minnesota's TCE ban, which Emily talked about pretty extensively. So I'll just kind of skip past this. This is our map of TCE use in Minnesota. It's pretty similar to what Emily was showing. As she said, primarily it's used for vapor degreasing, but there are other options or other applications such as solvents and formulations. Initially, we had 122 potential TCE users on our list. So far, we have crossed a lot of those out as either closed or already made a change. 15 confirmed users are either participating in the program or we're in contact with them and trying to convince them to participate in the program. And then we have another 50 companies on our list where we have still not been able to get a clear answer on whether they're using it or not. Maybe that we weren't able to contact them and get a response at all, or some of them we contacted and they said, oh, I'm not sure. And they were still in the process of looking into it and getting back to us. The steps in the TCE Alternatives project, first is to understand the current cleaning process. I'm going to focus this all on cleaning since that's by far the most common use. So first step would be to understand the current cleaning process and the process needs. Things that go into this would include what is the geometry of the parts? Are there blind holes? Are there small crevices in places where two pieces come together? As those are areas that can be more difficult to clean. What are the soils to be removed? What are the parts made from? And what is the level of cleaning required? We've had companies whose needs in cleaning range from, well, if it looks clean, that's good enough, all the way up to, maybe we need surface energy measurements. Maybe we can just do a white glove test, up to very technical microscopic methods and other things like that. We then collect samples. We help the company collect samples for performance and solubility testing at TURI and send those parts to TURI. TURI's lab identifies cleaning products and methods that may meet the process requirements with a variety of variables. And then once they have some promising options that work for this company's needs, then MNTAP takes back over and provides technical assistance to support the qualification and identify equipment and implementation, as well as sharing information on any grants and funding that may be available, including the low interest loans that Emily talked about. So TURI's testing process, first they select potential cleaners using their Cleaner Solutions database and evaluate the hazards using the P2 OASIS system. The soils of interest are put onto coupons of metal, usually metal, sometimes glass, that are made from the same material as the parts that they need to clean. And then usually TURI starts with immersion testing, starting with unheated immersion, followed by heated immersion, and then immersion with ultrasonics. And this is a picture of one of the coupons used in testing. So this is the clean coupon at the beginning. This middle one is the coupon after the oils have been put onto it. And then the third one is after cleaning. And you can see that in this case, it didn't really remove it very well. It just kind of moved it around. So at that point, we need to look at other temperatures. Maybe we might need to increase the temperature. If it's a cleaner that is diluted, we would look at potentially a higher concentration, maybe a longer cleaning time, or adding agitation or ultrasonics. Then once we have a sample process that seems promising, then TURI would test the actual parts that the company sent to confirm that that process works on the real parts. On the outreach side of the project, some of the outreach we did, we had a TCE Alternatives training in person on the university campus last summer. Well, I guess 2 summers ago now, 2019. We had 34 people attend, and that included people from industry, technical assistance providers, and regulatory agencies. We did make recordings of all those modules, so if anybody is interested, that training is available on our website. The background cleaning and TCE alternatives is kind of some of the stuff that I'm going to be covering in this presentation, but there is also some case studies and then a good information on how to use the Cleaner Solutions database and the P2 OASIS tools to identify possible options for alternatives. We also put out a TCE Alternatives mini webinar. The purpose of this was to try and keep companies engaged while everybody was shut down and staying at home. We made a series of 8 mini webinars, which were 2 to 4 minutes long. And we shared this by email and social media from June to August of 2020. We wanted to provide education and also continue to outreach and engage more companies in this effort to find safer alternatives. And these webinars are also available on MTAP's website. So the project status, we have 8 companies currently participating in the project. That includes the 4 that we needed to fill out the original MPCA EPA grant, and then 4 more that are being covered under the Water Gremlin Supplemental Environmental Project funding. And we have space for at least 2 more companies to participate. 2 of the companies are in the process of implementing their new solution. One has already identified a chemical, but they're in the process of selecting their equipment. 2 of them, the testing at TURI is complete, and they're evaluating their options to decide which combination of chemicals and equipment they would like to go with. And then there's 1 currently still at the stage of selecting and preparing their samples for testing. Overall, these 8 companies represent over 300,000 pounds per year of TCE use. So that far exceeds our initial 10,000 pounds per year goal. And we have 3 additional companies that we've contacted, and they basically declined to participate because they felt like they kind of had it under control already. And they are working with their suppliers to find alternatives on their own. But they did say that they would keep in touch with us, and we'll continue to touch base and see if there's anything we can do to provide support. So the current workhorses of cleaning, these are the cleaners that basically can be used in vapor degreasers, which is the main use for TCE. TCE, as we're talking about, commonly used in metal cleaning, and propyl bromide, I would say, is very often marketed as a safer replacement for TCE. If you look up online, TCE replacement, a lot of the products you find will be M propyl bromide and according to the marketing, you would think it was the best thing ever with no risks. PERC, as we talked about, is non-flammable and effective. It's not as often used in degreasing that we've seen anymore. There was actually efforts years back to have people change from PERC to trichloroethylene. Trans 1,2-dichloroethylene, which goes by TDCE, is another one of the very common substitutes for M-propyl bromide. It's often marketed as one of the replacements. And then hydrofluoroethers are another option that you can also use in a vapor degreaser. However, all of these products are hazardous. TCE, as we talked about, has cancer, liver, and developmental effects. M-propyl bromide was just recently added to the EPA's HAP list, and they found in their risk assessment that it caused unreasonable developmental and cancer risks when being used as a solvent or a cleaner. PERC also found unreasonable risk due to neurotoxicity and cancer. Trans 1,2 TDCE is actually currently in the risk evaluation process. It was on the list of next high priority chemicals, and it hasn't been, the risk assessment has not been completed, but it is underway. And because of the chemical similarity with the other products and initial information that's available, we don't really think it's going to come out as a lot safer. Furthermore, TDCE is flammable, so it needs to be mixed with a fluorinated product, or at least it's typically sold as a combination with a fluorinated product in order to reduce that flammability. And then HFE, hydrofluoroethers, those are the products that they usually mix with TDCE, and they're also used sometimes on their own. Fluorinated compounds are something that we generally want to avoid, and there is evidence that these actually break down into PFAS. So that's not something that we really want to recommend. So all of these chemicals that are potential drop-in replacements, we're considering them to be regrettable substitutions, and we're trying to get companies to avoid those. From the industry perspective, why don't the companies just change then? It's not that easy for them to do. First is getting reliable information. What options might work in their process. What is really safer? As I said, if you look up TDCE or M-propyl bromide online, it'll tell you it's the best thing ever, when actually it has some pretty serious health and environmental risks. And then will they work long term? If a company makes a switch, they don't want to find out 5 years down the line that now that product is being banned as well, and they have to make a switch again. It will require investment from the companies to make a change. Staff time, capital, in many cases, they'll need new equipment because, as I said, the drop-in replacements are not good options. And operational complexity. One of the benefits of using a vapor degreaser is products come out clean and dry. If you're using some of the other options, such as an aqueous cleaner, you very often will need to add a rinsing step and also a drying step, depending on the process conditions. And so just adding those extra steps is another barrier to companies. And then the impact to business, they'll have to retrain their employees. They'll have to often notify their customers and re-qualify the processes to make sure that the products still meet their customers' needs. And that can open them up to competition, because sometimes the customers will say, well, if I have to re-qualify your product anyway, might as well qualify your competitor at the same time. And that's something that they really want to avoid. From a source reduction perspective, the options for replacing TCE, ideally, maybe we can just get rid of it completely. This isn't very commonly found, but in some cases, they may be cleaning parts with TCE, and the next step that they're going into is another cleaning step. So maybe the TCE cleaning was really not required in the first place. We have seen this occasionally in plating, for example, because most plating baths start with a clean step. So if there's not too much contamination, we may not need to use that initial cleaning at all. Solventless processes would be things like sandblasting or CO2 blasting, or even just a dry wipe. Aqueous systems would be next. Obviously, this would be any kind of water-based detergent. After that, we would look at non-halogenated solvents, and then finally other halogenated solvents, which are the least preferred and we really would want to avoid. This is some information looking at analysis from the P2 Oasis tool. This is a tool that was developed by TURI and it's available for free to use on their website. You can put in a variety of chemicals and compare their environmental health and safety. A 2 is good and a 10 is the worst. If you look at this table, you can see TCE and M-propyl bromide both have a lot of red, with 8s and 9s and an overall average of 8.5 or 9.5. TDCE is maybe a little better, but there's still a lot of red and orange in there. And there's also a lot of unknowns that could influence this rating once more research is done. And then these are some of the the non-halogenated solvent options that we are looking at in our process. You can see we're getting into more greens and yellows now, and then some of the aqueous alternatives. So this is a list of the recommended safer cleaners. All of these products have been in testing as part of our work with TURI and the TCE Alternatives project. They're all products that we expect could be effective. That isn't to say that they necessarily will be effective for any given process. The effectiveness will vary depending on process needs. And that's one of the obstacles to making a change away from TCE is that TCE and the similar vapor degreaser cleaners, they pretty much work for anything. You put any kind of dirty part in there and it will come out clean. While there are very effective, safer alternatives, they don't tend to be as wide ranging. It's more like you have to pick the specific option that's going to work for your specific situation. So over here on the right, we have a number of alkaline aqueous cleaners, water-based. We also have a detergent, a powder detergent that you add to water. Aussie Juice is interesting because it's an aqueous cleaner that has a microbial component in it, and the microbes actually eat the oil. Not so much to eat the oil off of the parts, but more to rejuvenate the cleaner and remove the oil from the cleaner so that there can be less hazardous waste and that your cleaning product can last longer. And then a variety of non-halogenated solvents, which would be a modified alcohol, some ether, glycol ether, and esters. This is a real rough picture of some of the costs that we're looking at. We don't have cost information on too many things yet because not a lot of our customers in this project are all the way to the end where they've actually purchased the new cleaner and purchased the equipment. So some of these are a range of information found online. Some of these are an actual point in time information that we got from somebody that we were working with. But TCE, we're finding, runs about $17 per gallon. And the other drop-in cleaners are all more than that. But M-propyl bromide is about $43 per gallon, up to some of the engineered, more highly engineered solvents are up to $182 for the Novec per gallon. But all of these are products that we would not recommend as they have hazards, as we discussed. So Dowanol is a glycol ether. This one can be used with immersion and it costs about $93 per gallon. Metalnox is a modified alcohol and is costing about $33 per gallon. This dimethyl glutarate, I'm not sure on the cost of this. We have a $621 price point. Hopefully we can find that at a cheaper rate, but that's what we had initially. I think that may be for lab quantities. And then method dish soap is obviously just a regular consumer detergent that you can purchase, but we have had success in some of TURI's case studies using that as an alternative to TCE, and that is about $21 per gallon. Then we have a company that was a powder coater, a painter, and they were looking at just switching to an aqueous phosphate system. All of the ones that are not for vapor degreasing will require some kind of equipment upgrade. Immersion cleaners generally will range from about $300 to $6,000. The vacuum degreaser, Metalnox is flammable, so it needs to be placed in a vacuum degreaser. And that is quite expensive equipment with a price point of around $400,000 per machine. And then the quote that we had for the phosphate system, which is basically an automated paint line spray washer, was about $80,000 plus water treatment. So to use these aqueous cleaning systems, often you'll need to have deionized water or even reverse osmosis water. And this particular facility did not have any current water treatment. So in addition to buying the new system, they also would need to purchase a water cleaning system. One thing to note here, in addition to the prices being kind of rough, is that when you're changing from a vapor degreaser to a completely different cleaning process, the quantity of chemical is likely to be significantly different. So even though we have price per gallon here as kind of a starting point, that usually probably doesn't tell the whole story as far as what will the cost, will they be really going up? I wouldn't expect that they would be going up as much as this may indicate, because often we'll be able to use less product. So I'm going to get into the equipment now and look at some of the various options. So a vapor degreaser, this is what most people are currently using with TCE, has the benefit that it doesn't require rinsing or drying. There's varying levels of containment for the solvent, ranging from this one, which is open topped. You just open it up and lower the parts right into the TCE. This one is a little bit more enclosed. The TCE is in here and the head space is all enclosed, but when you bring the parts back out, they're just out in the open air. And then this one is more fully enclosed, where it has a little drawer to take the parts for introducing and taking the parts out. And it's interlocked so that a vacuum will clear the air out and try to remove the TCE vapors before that door can open. This would not still qualify, I'm pretty sure, as a system that is entirely enclosed, as what we had talked about earlier. It's maybe getting close, but I think it would not meet the requirements for that. Ultrasonics cleaners, these are most commonly, what we most commonly would recommend for people who are looking at aqueous cleaning solutions. They can also be used with non-flammable solvents, and in some cases, usually on a small scale and with special precautions, they may also be able to be used even for flammable solvents. But for some, mostly for flammable solvents, you need something more complicated than this. These usually come with options for heat or rinses if necessary, and automation to remove the parts. This one down here on the left has a automated part mover, so it can move it from the wash tank to the rinse tank. Benchtop units, such as these two, can range from $80 up to over $1,000. This one is available at Walmart for $80. And then larger units can range from $2,000 to over $100,000. And some of our companies are very price sensitive to new equipment. They, in many cases, feel like they were going along happily using TCE, and this change is kind of being pushed on them. And it's already difficult, and they don't want to spend a lot of money, or they don't have a lot of money to spend. And as a way to try to make that easy for them, we have also been looking at used equipment. So this is an example of a used ultrasonics cleaner that we found online for about $2,500. And I've seen these in the tens of thousands of dollars if they're new. So hopefully that's something that some companies can take advantage of as well. Spray cabinets are another option. They typically would be used with aqueous cleaning solutions. They have automated operation, so their benefit is you can just put the parts in, walk away while it does the cleaning cycle, and then come back and take out your clean parts, which is kind of more similar to how vapor degreaser works. One drawback is that in a lot of these designs, the small parts would have to be racked so that the spray can reach all angles. However, there's some options where the design is a little different. Here, they're just in a basket that spins, so you won't have to do as much of a careful arranging, and the spray can kind of come at them just by putting the parts in. And these range in price from $2,500 to upwards of $10,000. A vacuum degreaser, these are recommended for use with flammable solvents. They also can be used with non-flammable solvents and even aqueous systems. These are considered a totally enclosed system. Emily talked a little bit about not having anything that qualified as a totally enclosed system, and I'm not sure what the specific requirements that they're looking for are and whether all of these would meet it or not, but I know that this middle one came from a case study that Terry had, and I believe that they were considering it to be totally enclosed. So that was something in Massachusetts, and I can try to find, if you look at Terry's website and you look for the case study about Litron, that is the one that they talked about, where they switched to an enclosed an enclosed system. I think first they went to an enclosed system, but still used TCE, so it didn't eliminate, but greatly reduced the TCE used. Then I think they changed to TDCE, and they were looking at hopefully a further change in the future to get something that would be more truly safe. One major subset of vacuum degreasers is called vacuum cycling nucleation. In this situation, you have your parts and there's a reservoir that you pull a vacuum on it, and that causes cavitation bubbles to form on the part, they especially form in the small tight areas or porous areas, which would normally be very hard to clean. And then that vacuum is cycled on and off really rapidly. And every time you pull a vacuum, more bubbles form, which pushes out the dirty solvent and the contaminants. And then when you turn the vacuum off, the clean solvent can rush back into those areas. And by doing that back and forth, you get really good cleaning of those areas that are pretty hard to get at with anything other than vapor degreasing otherwise. These machines, however, are very expensive. One price point that we got was that they are about $400,000 per machine, and they don't necessarily have the same capacity as a large vapor degreaser. So you may need to do multiple of the machines in order to meet the capacity that you had on your old cleaner. So it's a very significant investment. I'd like to talk just a little bit about considerations for project replication. So if other people are going to work on this, identifying safer alternatives, there are resources available. Turi's Cleaner Solutions database is a great alternative for that. You can see all their test results and what they tested it on and what was effective and what was not effective. If they don't find anything within that looks like it will be effective, or if they find something that looks like it will be effective, but then when they test it, it's not, they can go further to use Hansen solubility parameters. This is a method that can figure out the solubility parameters and then identify other chemicals that would have those same parameters and therefore likely able to dissolve the same contaminants. However, those are not necessarily going to be safer options what comes out of that. So you can then pair that with the database of safer solvents, which Turi also offers, in order to make sure that you're using only safe alternatives out of the list that comes out of the Hansen solubility program. If this testing was to be done on a large scale, additional testing options and capacity will be needed. If every state decided to do a project and start sending 4 to 6 companies to Turi for testing each year, they would definitely not be able to keep up with that. So some questions that we're wondering about is, are there other regional centers similar to Turi that could do the testing? Or also could we contract out to have this testing done at private labs? Streamlining of the test protocols is something that we think would make the process go faster and be more cost effective. This would be important if we were going to do contract testing. We would need to provide them with protocols, exactly how to do it, because while they would have the lab skills, they wouldn't have the knowledge about the cleaning and the safer products. And then if companies were going to do it on their own, having those streamlined protocols would also help. We thought that creating predetermined sets of alternatives that are most likely to be effective could also help. So if you said, hey, I have parts that are stainless steel parts with this type of cutting oil, then maybe we could say, well, here's the first 4 solvents that you should try, and kind of give people something that they could get started more easily, and then save the skilled consultants at Turi, for example, for the projects that are more difficult when those initial recommendations don't turn out to work. And then also for streamlining the testing, we could look at combining a set of various cleaners or various test conditions like multiple temperatures in order to conduct multiple tests at once and get those to go faster. We also found that pressure to act fast has resulted in some companies following the path of least resistance and choosing a regrettable substitution. As we talked about, there's a number of drop-in cleaners available, and the information in their marketing says that they're safe and effective, although that's pretty questionable. But when companies were told, you need to get rid of the TCE, they had to make a choice in order to keep their business going. And so we think that it's really important that any initiatives to either ban TCE or just get companies to make a change is allowing them the time to explore the options and do the necessary process development work so that they can get to the truly safer options. And then just finally, I wanted to talk a little bit about the motivations for companies. Although Minnesota has now banned TCE, and that will be quite a motivation for any of the remaining companies that are using it. Most large users in Minnesota were already engaged in our program before that ban was passed or before it even looked likely to pass. The primary motivation for them getting involved, I would say, was the negative publicity due to the water gremlin situation and the related increased scrutiny from MPCA related to that. So the question would be, how can we translate this to businesses in other areas without them having to have a crisis of their own in their area? The information is out there, but I think we have to find a way to make it hit home like it did for our local businesses. And then just want to wrap up with saying most companies are not going to be able to find their way to the truly safer alternatives on their own. The information, the suppliers and equipment vendors online will promote the regrettable substitutions. That's the easiest thing to do, and it works in the company's existing equipment. Companies really need help from technical assistance providers and other people like that to make the larger process changes so that they can get to a truly safer option. And that's the end. So if anybody has any questions, I would be happy to try to answer them.
Jane, this is Mark Stoddard. Do you find any motivation to the use of any of the solvents that are considered VOC exempt solvents under the Clean Air Act?
I haven't. What I've mostly seen people who are looking for the quick change is they're either going to N-propyl bromide or the TDCE. I think TDCE might be exempt, but that doesn't seem to be a big factor in why they're changing. I mean, I haven't seen anybody considering a change to PERC, for example.
You mentioned HFEs, but HFOs are also VOC exempt. And you mentioned one product named Novec. I think they make a product that's also VOC exempt, but they do get to be more pricey. So it really depends on your usage. So if you had a vacuum system where you're able to capture the solvent and you're not losing a lot of it, then maybe price of that solvent wouldn't matter a lot.
Yeah, I know there is a number of different Novec formulations, and I just happen to have a price point on that one, and that's why it's the only one in our list. And they're made of very different things. I know some of them are TDCE, and that one was a fluorinated product. So I guess the VOC exempt things are out there. I haven't had anybody express to me that that was one of their major concerns. I think that they're not, I mean, I guess they would probably consider that a plus, but it doesn't seem to be a primary motivator for people that I've talked to.
Oh, okay. Do you find, I had, a situation a few years ago, 3 or 4, maybe 5, there was a contamination of TCE found in drinking water wells. So that was again a motivation to start looking at alternatives to TCE. And so it gets back into fear of something bad being happening, and maybe it potentially affecting you. Maybe if just anything, bad publicity.
Yeah, bad publicity seemed to be very much a factor in the companies that we were working with. It wasn't just the regulatory things that they were concerned about, but they were very much concerned about the publicity. In fact, even to the point where a lot of the companies that are working with us and they're doing the right thing and they're finding a safer option, they don't want their name in the same sentence with TCE at all to say that they were using it. So we're having a hard time getting companies to agree to case studies or anything like that, because they just don't want the publicity that they were a former TCE user either.
Oh, yeah. From the standpoint of a company having an environmental management system where maybe they start looking at reducing their impacts on the environment, have you found this is looking at it not from the glass half empty, but the glass half full? Are they now looking at, yeah, this is a big, this is a significant aspect, and we're looking or motivated to look for alternatives?
I guess a lot of the companies we're working with are really small and they don't necessarily have that sort of plan. And the larger ones, they probably see that again as something nice to be able to show improvement on there, but they're mostly concerned about the negative publicity still.
Okay.
And so, Jane, great presentation by you and Emily. And sounds like you don't work too many aerospace. You don't have aerospace manufacturing where they'd be. I put a question in the chat about cleaning landing gear. I think with most of the large aerospace manufacturers, that is kind of their limiting point. They want to keep TCE for cleaning the landing gear just because that's such a critical use.
We don't have anybody that's like building actual airplanes. We do have companies in the aerospace industry, and we have a lot of businesses in the similarly highly regulated medical device industry. So I guess as far as the specifics to landing gear, I don't know that we have anybody that makes landing gear in particular, but we do have a lot of companies that are highly regulated industries, and we're finding that it just makes the process longer. So, you know, they probably wouldn't, well, they may be less likely to have done something if there wasn't the motivation of massive negative publicity plus regulation. But now that there is, they are able to make the change. It's just taking a lot longer because they have to, first of all, be very sure that it's doing an effective job and not having any impact on their products. And then they need to take the time to also share that with their customers and make sure the customers approve that change. So it's a long process. And as far as the actual TCE reductions, I was going to say, we have only 3,000 pounds of TCE reduction actually implemented so far at this point. And what we're finding is if a company has a large TCE vapor degreaser, and they're working on gradually qualifying their products and changing them over and getting customer approval to change them to their new system, they can't actually get rid of any of the TCE in that large cleaner until every product is transferred over to the new system. Then they'll be able to get rid of it all at once. So we're finding that it's not a gradual decrease of TCE throughout this project, but we're expecting it to be more a lump sum at the end.
So from Nancy's perspective, if I recollect properly, I think one of the issues with aerospace is, and I don't know a lot about FAA requirements, but maybe specifications on the use of certain cleaning materials for critical parts and for medical equipment, perhaps not knowing FDA rules that well, but getting FDA approval, perhaps for the use of certain cleaning materials for certain medical devices itself. So I don't know if that adds barriers or hurdles, or that gets into exceptions, perhaps, or variances, maybe.
Yeah, I don't think Emily can maybe talk more on it, but I don't think that that Minnesota's ban is including exemptions for those types of things. And my impression is that it definitely makes it more difficult and does give more hurdles to jump through in order to complete the change. But I think they're usually able to ultimately make the change. They also are less likely, they don't want, if you have a product that's approved by the FDA and it's approved, you just want to leave that well enough alone and not open any can of worms with making changes. But if you do have to make a change, which they do every few years, there's often a couple changes that they need to make. They try to save them up and do them all at one time. This is that kind of thing that would spur a necessary change, and it is possible to do typically. I don't know about the specifics of landing gear and.
So I'm wondering.
But I know also military specifications has been mentioned.
Oh, yeah.
And I believe that there are alternatives that are available now for that as well. But those have been, some people I know, they said that they were making changes, and their things that fell under military specs was the last ones that they weren't able to change at first, but they ultimately did manage to change them.
I'm wondering about success stories. I'm thinking success begets success. So I don't know if any of these places you're working with would be potentially willing to kind of be showcases for, yes, we were a little reluctant, but we had Minnesota come in and we were able to work through this and find success, because maybe other industries may be a little suspicious of the state coming in and saying, well, you ought to do this, but maybe a peer would be more of a motivation for them to maybe break the logjam.
Yeah, well, like I said, we certainly would hope to do that too. We're finding that most of the companies are very publicity shy, because they just don't want their name associated with TCE in any way, even if the association is, we did the right thing and got rid of it. But we're hoping that we will still find some companies willing to do that. We really only have 2 that are at the point where they could start to think about writing a case study about them anyway, because they have their, they have their product, they have their equipment, and they're in the process of putting it into effect. The ones that are not quite there yet, we haven't asked them about doing a case study because we don't really have a full story to tell at this point. And I'm hopeful that some of them might be a little bit less publicity shy, but we don't know for sure. Turry in Massachusetts does have a number of case studies and success stories with companies that have been willing to share their story. I'm not sure if they make that a requirement of working with them, or I should talk to them about how do they convince these companies to allow this information to be published. But they do have some there. So as far as a resource of a company saying that this was effective and, we got some help and we made a choice and we made a change to something safer and got rid of TCE, there are at least some out there. And I found the best way to find the case studies on, excuse me, on Turry's website is just to do a Google search for Turry case studies, and it'll take you to the page where they list all their case studies, because I've had trouble finding it otherwise.
Well, I want to thank you, Jane and Emily, for taking time to develop and give your presentations. They were very informative. I'm hoping that everyone who was not able to participate today will find, when viewing the presentation later, equally a benefit to them as well. And hopefully this does spur maybe more discussions and maybe greater progress toward moving forward as far as safer environment.
Yeah. Well, thanks for having us.
Donovan, do you have anything to say?